Let's jump right into this explainer. Today, we're unpacking a really wild environmental paradox. It's about how a super well-intentioned law, one that was literally designed to save millions of gallons of water, actually ended up sparking a deadly public health disaster in the sky. We're looking at some fascinating research out of Nature Sustainability that dives into a highly complex situation in northwest India. It's basically a classic, though pretty tragic, case of unintended consequences. Where trying to fix one crisis accidentally turbocharges another.
To really grasp the stakes here, we have to look at the human cost, and it's heavy. Every single year, an estimated 16,000 premature deaths in the New Delhi capital region are caused by these catastrophic, choking spikes in air pollution every autumn. This haze brings the entire megacity to a total standstill. We're talking severe travel delays, schools shutting down, rampant illness, and ultimately an aggregate drop in life expectancy of about 6 years for the folks living there. So yeah, this isn't just your run-of-the-mill smog, it is a full-blown public health emergency.
Now, you might automatically assume all this toxic air is just coming from city traffic or local factories, right? But here's the crazy part. During late October and early November, up to 70% of this hazardous fine particulate matter, what scientists call PM 2.5, doesn't even originate within the city limits. It's actually blowing in directly from neighboring agricultural states, specifically Punjab and Haryana, because farmers there are burning off their leftover crop residue.
So why exactly are they burning it? To understand why farmers in India's breadbasket are setting fire to roughly 23 million tons of rice residue every single year, we've got to rewind back to the 1980s. See, the introduction of combine harvesters completely revolutionized farming over there, but it left behind this massive amount of stubble. And because working that residue back into the soil is expensive and takes a lot of time, well, farmers realized setting it ablaze was just the fastest, cheapest way to clear the fields. They had to get their winter wheat planted on time to keep their crop yields up.
And this brings us to the absolute heart of our story. We've got a massive structural clash going on. On one hand, a severe public health emergency up in the air, and on the other, a terrifying national food security threat brewing underground. Because while the air pollution was getting worse above, the groundwater in Punjab and Haryana was draining at this really alarming rate due to the heavy irrigation you need for rice farming. Subsidies, like giving farmers free electricity for irrigation pumps, basically incentivized overpumping. Policymakers were literally staring down the barrel of a dual crisis.
So, to stop these critical aquifers from running totally dry, state governments decided they had to step in. They enacted the Groundwater Acts of 2009. This legislation made it legally binding for farmers to delay transplanting their rice until mid-June. And the logic? It was totally sound. By waiting until closer to the monsoon rains, farmers wouldn't have to rely so heavily on pumping groundwater to flood their fields. And you know what? Simulation studies showed it actually worked. Groundwater depletion really slowed down.
But here is where the story takes a turn, and we get this tragic butterfly effect. Pushing that planting timeline back forcibly delayed the harvest by an average of 8 days. And since farmers still desperately needed to clear their fields fast to plant their winter wheat, this shift shoved the entire intense burning period right into a colder, much narrower window of time.
Here's the real kicker. While the total volume of stuff being burned didn't necessarily change, the intensity of it completely transformed. Before the 2009 acts, fires used to peak around late October at about 490 fires per day. But after the acts, because that window got so compressed, the peak fire intensity shot up to 681 fires per day by early November. That's an unbelievable 39% jump in peak fire intensity.
And as we know, timing is everything. By pushing all that burning into November, the smoke essentially hit a meteorological brick wall. Compared to October, November temps in New Delhi drop by about 3 degrees Celsius, and the winds become dramatically weaker. This creates severe atmospheric stability. Basically, the cold, still air just refuses to let the pollution disperse. It acts exactly like a heavy lid, trapping all that toxic smoke right over the entire region. So what was the fallout from this shift? Well, this totally well-meaning water conservation law inadvertently triggered a 29% spike in daily average PM2.5 concentrations in New Delhi during November. Researchers found that, both relatively and absolutely, the pollution jump in November was way higher than in any other month, which heavily points the finger directly at these delayed agricultural fires as the main culprit, rather than just some general uptick in city emissions.
Looking at all this, it raises a profoundly difficult question for policymakers. Are we looking at a zero-sum game here? Like, do we literally have to choose between preserving the water we drink to secure our food supply And the air we breathe to stop thousands of premature deaths?
The tension is incredibly stark. Researchers point out that while the acts totally succeeded in protecting those groundwater reserves, the environmental toll didn't just magically disappear. Actually, scratch that. It didn't disappear at all. It just relocated. It moved from the aquifers under the ground straight up into the atmosphere above it. It's such a vivid example of just how deeply connected our farming practices and environmental systems really are.
Okay, but it's not all doom and gloom. A path forward does exist. We don't have to stay stuck in this awful trade-off forever. The researchers say it just takes a more integrated approach. For example, deploying these machines called Happy Seeders, which is a great name, they actually let farmers plant wheat directly into the rice stubble without burning a thing. Or growing shorter duration rice varieties, which lets the harvest happen earlier and spreads out the burning so it isn't all bottlenecked in November. Plus, fixing energy subsidies to reflect the actual cost of power could naturally stop the overpumping, so we wouldn't even need these strict planting bans in the first place.
And get this, there is some real optimistic momentum building. To jumpstart this whole transition, the Indian government rolled out a $157 million initiative specifically to fund these new agricultural machines. The entire goal is to give farmers the tech alternatives they need so they aren't forced by economic pressure to just set their fields on fire.
So, as we wrap up this explainer, this research really hits us with a profound realization about global agriculture. As the researchers put it, there are no simple solutions at the nexus of food security, resource depletion, and environmental quality. It leaves us with a critical question for any future policy. When we pull on one thread of an ecosystem to fix a specific problem, how can we ever be absolutely sure we aren't unraveling another?